Hello students, and welcome back to another geometry video. You know what to do. Please pause the video and try this problem in your notes, then unpause the video to do it with me. Okay. Given the measure of angle 1 is 105 degrees, find the measure of angle 4, the measure of angle 5, and the measure of angle 8. Tell which theorem you used in each case. Okay. So first, let's start with the measure of angle 4. The measure of angle 4. Aha! Well, look at that. 1 and 4 are vertical angles. Two lines that are crossing each other, and 1 and 4 are on the opposite sides. So the measure of angle 4 is the same as the measure of angle 1. It's 105 degrees because of the vertical angles theorem. Okay, next, I hit my knee, that's okay. Next, the measure of angle 5. Well, the measure of angle 5, ooh, look at this. 1 and 5 are corresponding angles. And because, look at these red arrows, that means that these lines are parallel. And if the lines are parallel, that means, that corresponding angles are congruent. So the measure of angle 5 is also 105 degrees. And that is the corresponding angles theorem. Okay, lastly, it wanted us to find the measure of angle 8. My diagram's getting a little messy, so I'll erase it. The measure of angle 8. Oh, look at this. Alternate exterior angles. So that means the measure of angle 8 is also 105 degrees because these lines are parallel. If my lines are parallel, then alternate exterior angles are congruent. So this is the alternate exterior angles theorem. Ta-da! So we found each angle measure, and we stated the theorem for each. So we are done. That was a nice review from yesterday. Now, let's see what we have for today. Today is all about section 3.3. I know it says proofs with parallel lines. Today in this video, we're not going to get super proof heavy, but we will be doing proofs, but you won't even know they're proofs, trust me. So, our learning target is that you know what makes lines parallel. If this, then lines are parallel. What? If what? If what, then lines are parallel. And the success criteria, how will you know that you know if, then lines are parallel? How will you know that you've truly learned that? Well, you'll be able to determine whether lines are parallel or not. If this, then lines are parallel. So you should be able to determine whether lines are parallel or not by the end of this lesson. So, first, we're going to talk about some converses. Now, you'll remember from chapter 2 that what the converse means is I switch my hypothesis and my conclusion. I take the if and I take the then and I switch them. If I'm eating a fruit, then I'm eating a banana. Switch that. If I'm eating a banana, then I'm eating a fruit. Okay, so, and I am aware that the first sentence was not true, but remember, switching our converses, switching our hypothesis and conclusion, making converses, doesn't necessarily mean that we have a true statement. So, if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. Huh. This is the exact opposite of what we learned in the last lesson. Last lesson, it was if the lines are parallel, then corresponding angles are congruent. Now, we have if, well, let me write it here a little bit. If corresponding angles are congruent, then the lines are parallel. Or then, in our case, J and K are parallel. So notice that in this diagram, I don't have any little red arrows, because the red arrows mean that the lines are parallel. And in the beginning, I don't know that the lines are parallel. All I'm told is that angle 2 is congruent to angle 6. And what we're saying, what this theorem is saying, is that if corresponding angles are congruent, if angle 2 is congruent to angle 6, then J and K are parallel. So we don't get those red arrows until we can say, corresponding angles are congruent, then the lines are parallel. So this is the exact opposite of what we talked about in the last lesson. If corresponding angles are congruent, then the lines are parallel. Okay, so we're going to hear about the other theorems. I know, you're like, wait a minute, wasn't there an alternate exterior, interior theorems? Yes, we're going to talk about more theorems, but first, I'm going to show you an example of this one, the corresponding angles converse, then we'll jump into the other theorems. So our first example uses the corresponding angles converse. So it says, find the value of x that makes m parallel to n. Remember, if corresponding angles are congruent, then the lines are parallel. So, this angle right here, 3x plus 5, and 65 degrees, these angles are corresponding angles. So, if 3x plus 5 equals 65, then m is parallel to n. So if we solve this for x, we'll get a value for x. If x equals that number, then m and n are parallel. So when it says find the value that makes m and n parallel, well, if corresponding angles are congruent, then the lines are parallel. So let's solve this equation right here. And I'll use a different color. Minus 5, minus 5. 3x equals 60. Divide by 3 on both sides, and we get x is equal to 20. So if x is equal to 20, then m and n are parallel. And we can check. If I plug 20 in here, 3 times 20 plus 5, 60 plus 5, yes. This is 65. 65 is congruent. 65 is equal to 65, so these angles are congruent. Beautiful. So, our final answer, x equals 20. That is the value of x that makes m and n parallel. Beautiful. Okay, now, we can check. Let's check. Yes, m and n are parallel when x is equal to 20. That's what we got to. Yay! Alright, next, now, let's go back and talk about our other theorems. Alternate interior angles converse. All the theorems we talk about today are going to be converses because they've switched the if and the then. They've switched the hypothesis and the conclusion from our theorems from the last video. So now, if two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. So you'll notice a pattern in these theorems too, just like we noticed a pattern in the last theorems. The pattern here is that we always start with if two lines are cut by a transversal, so the alternate interior angles are congruent, the corresponding angles are congruent, whatever. then the lines are parallel. So each of our theorems today will start with, if the two lines are cut by the transversal, so the alternate interior angles are congruent, then the lines are parallel. This part will be different for each theorem. But because it is the alternate interior angles converse, we're talking about alternate interior angles. So if alternate interior angles, we're abbreviating alternate interior angles. If alternate interior angles are congruent, then the lines are parallel. Okay, so if angle 4 and angle 5 are congruent, then line J and line K are parallel. Similarly, if two lines are cut by a transversal, so, same thing as last time, but now, so the alternate exterior angles are congruent. Last time we talked about alternate interior angles. This is alternate exterior angles. Then the lines are parallel. So if alternate exterior angles, we're abbreviating again, if alternate exterior angles are congruent, then J and K are parallel. Line J and line K are parallel. So if angles 1 and angles 8 are congruent, then line J and line K are parallel. Okay, and lastly, the consecutive interior angles converse. If two lines are cut by a transversal, so, same thing. So the consecutive interior angles are supplementary. Remember, consecutive interior angles. One's acute, one's obtuse. Obviously, they're not going to be congruent. There is one special time where they will be congruent, but otherwise, they are supplementary. Well, they're always supplementary, but there's one special time that they're congruent and supplementary. But that's one special time. Otherwise, they will typically be different, but they will always be supplementary. If consecutive interior angles are supplementary, then the lines are parallel. So if consecutive interior angles are supplementary, then J and K are parallel. If they are supplementary, then line J will be parallel to line K. So if 3 and 5 are supplementary, if they add up to 180 degrees, then line J will be parallel to line K. Let's jump in to our last example for today, determining whether lines are parallel. So in the diagram, we know that line R and line S are parallel. And we know that angle 1 is congruent to angle 3, so I'm going to mark them with little tick marks like that. Is P parallel to Q? Why? Okay, so we know that these are parallel. We want to know, is P parallel to Q? Can I make these red tick marks? Yes or no? Well, let's find out. Angle 1 is congruent to angle 3. Let's start with that. Angle 1 is congruent to angle 3. We know that. Okay. And what else could we figure out from this? Let's see. If we could find out... Oh, wait! Okay. Here. R and S are parallel. Yes? Yes. Because they said in the diagram, line R is parallel to line S. That means that angle 2 and angle 1, if the lines are parallel, then corresponding angles are congruent. So, angle 1 is congruent to angle 2 because the corresponding angles theorem, because R and S are parallel. And look at that. 1 is congruent to 3. 1 is congruent to 2. That means that angle 2 must be congruent to angle 3. Because angle 3 and angle 2 are both congruent to 1. And 1 is the same thing. Therefore, 3 and 2 must be the same thing. So remember, this is the transitive property of congruence. And wait a minute. If 2 and 3 are congruent, so now let's zoom in on 2 and 3. If angle 3 and angle 2 are congruent, when I look, let's get a little bit bigger. When I look at line P and line Q, angle 3 and 2, they are alternate interior angles. And hey, if alternate interior angles are congruent, then the lines are parallel. So, because angle 2 is congruent to angle 3, then P is parallel to Q by the alternate interior angles converse. Now I know this diagram might have been a little difficult to read because there's 4 lines here. Like we have R, S, P, and Q. Normally, I know what you're thinking, normally we just have 2 lines in a transversal. So this problem was a little bit more challenging because it required you to look at these 2 parallel lines and then this transversal. So you kind of had to take line P and you had to imagine that line P wasn't there. And then you had to look at lines P and Q with R as the transversal. And you had to try to imagine that line S wasn't there. So when you're doing problems like this, if there are problems like this on your homework, maybe you'll just have problems that do look like this. Depends on what your teacher decides. But if you see problems that look like this on your homework, you have to say which are the lines that I'm thinking are parallel and what is the transversal. Now, if you're looking at P and Q, either R or S can be your transversal. Doesn't matter. It depends on what you're looking for. For us, we were looking for a relationship between angle 3 and angle 2. So we wanted to look at R being our transversal. And in the beginning, when we looked at these 2 lines, we wanted to notice the relationship between angle 1 and angle 2. So we wanted Q to be our transversal. So make sure you're paying attention to which lines am I looking at and what is my transversal. Okay, so we determined yes, P is parallel to Q. Why? Because of the alternate interior angles converse. So, let's check and make sure that we were right. Angle 1 is equal to angle 2 because R is congruent to S. If angle 2 is congruent to angle 3, then P is parallel to Q. So, corresponding angles theorem, transitive property, alternate interior angles converse. Woo! Woo! Beautiful. That's exactly what we said. Exactly what we said. Okay. If you have questions, please ask questions. Questions are good. We love questions. So please ask questions if you have them. Of course, here are some problems you might see on your homework. Notice how some of them have 4 lines and some of them just have the 3. Try both of them. Make sure you're comfortable with both of them. See, some of them have 4. But remember, of course, these are not necessarily your homework problems. Do the homework that your teacher says, not these problems. But if you're doing it for fun, go ahead and try these problems. They match up with the examples we did. And, of course, let's end our lesson with a launch. Today's launch comes from Malala Yousafzai. Ooh, I probably butchered that. But they say, let us make our future now, and let us make our dreams tomorrow's reality. Let us make our future now, and let us make our dreams tomorrow's reality. So when you think about in the future, in the future, I want to be a nurse. I want to have a house. I want to write a book. Whatever it is. Make your future now. You want to be a nurse? Look at colleges that let you become a nurse. Figure out how to become a nurse. Make your future now. And when you say make your future now, it doesn't mean that you are a nurse now, but that you are making your future now. Every day you are working toward that future that you want. If you want to write a book, start a list of books that you'd like to write. What do you want to write your book about? An alien race that discovers love? I don't know. Write out the titles. Start thinking about what books you want to write. Heck, start writing the book. Whatever future you want, start making it now. Because the more of a plan you can make, the easier it will be to get there. And your dreams. Make our dreams tomorrow's reality. That goes with what I was saying earlier. Plan for the future. Plan for your dreams. Because you determine whether your dreams become reality or not. You determine whether or not you write your book. You determine whether or not you become a nurse. It's up to you. You might have to work a little bit harder than other people because you don't have as much money or whatever. You might have to work a little bit harder, but you can do it. I know you can. And if you need help, there are always people here willing and wanting to help you. So that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.